Alright guys, so this should be a lesson, topic 64, that you should at least try to do Monday. Look through the lesson. I wouldn't say that this is difficult, but it's very easy to get lost. So make sure you can keep up. When I come back on Tuesday, you can ask me questions, and then we'll just move on from there. Anyway, so we're going to actually do something called U substitution. Now, U substitution is basically undoing the chain rule. Alright, so we can talk about the theorem and all that, but let's not do that, because the reality is that we don't want to spend a whole lot of time on this, and I want to give you examples. So, again, the U substitution is going to undo the chain rule for us. So, there's 5 steps you need to follow, and the steps are relatively simple. Now, how to do it could be difficult, but the concept is not too bad. Alright, so you're going to choose a value for U. Now, on all of your homework and on this, they're just going to tell you what U is. So you don't necessarily have to worry about step number 1. Now, the second step, and I'm going to do it as I'm talking about it, is you're going to take the derivative of U. Alright, so if I take the derivative of U, right, and in this case, I'm going to take the derivative of U with respect to x. So I have du dx. The derivative of x cubed plus 5 is just going to be 3x squared. Right? So again, this right here is the derivative of U. Derivative of U. Okay? Now the next part is, are you going to make a substitution into the original problem? This is how you're going to do that before you do that, okay? This right here, I can treat this as a fraction. It's not really a fraction, but I can treat it as such. So if I multiply both sides times dx, right, what I'm going to get is that du is equal to 3x squared dx. So this is what I'm going to do. I'm going to replace this stuff inside of here with this, and I'm going to replace 3x squared dx with du. Alright, so that and that are going to be the same thing now. Okay, so let's see if you can follow. So what I'm doing now is I'm going to replace, instead of writing 3x squared dx, I'm going to write du. And instead of x cubed plus 5, I'm going to write u, because that's what I did from the beginning. Or that's what I chose u to be. So this is going to be u to the power of 9. Alright, so this is actually the key to it. So if you're okay with this and you're doing good, the rest of it is actually pretty simple. Alright, so one more time. The homework problems here, they're going to give you what u is. U is this. And you're going to have to take the derivative of this, which will give you 3x squared. And then you're going to move this dx over here by multiplying both sides times dx. And that's going to give you this. You will then replace 3x squared dx, those two, with du. And now you're going to integrate this, which is a lot easier to do. So this right here is going to be equal to u to the 10th power over 10. So now I'm taking the antiderivative plus c. Now once you're actually done with that, you're going to actually substitute back. What I mean by that, instead of u, I'm going to come back and rewrite x cubed plus 5. So I have x cubed plus 5 to the power of 10 over 10 plus c. Right, and that would be your answer. Alright, remember to rewind if you didn't understand the first time, but I'm going to do actually 6 examples, so hopefully by the end of it you'll get it. Alright, so let's do example number 2. On example number 2, same thing. They give you what u is, and now you're going to have to find the derivative of u with respect to x. So we have du dx here. I'm going to write it over here. Du dx is going to be equal to 2x. Alright, and if you look at your problem ahead of time, notice that you do have 2x, which is good. So you don't have to do a whole lot of work here. And the next thing I'm going to do, which I'm not going to write, is I'm going to multiply both sides times dx. So, well, I said I was not going to write it, now I am. So du is equal to 2x dx. And one more time, I want to replace x squared with u. So x squared is going to be u now. And 2x dx is going to be du. So I'm going to rewrite this like this. We have cosine of u du. And now this is a whole lot easier to integrate. So that right there, the antiderivative of cosine is sine. So we have sine u plus c. That's it for that. And then the final step is to substitute back. So instead of writing u, I'm going to substitute u with x squared. So we have sine of x squared plus c. And that is the answer. Right? If you wanted to check your answer, you can do the chain rule. And when you do the chain rule, you should get back to this equation. Okay? Let's go over to example number 3. Same idea here. Same idea. I'm going to rewrite this before we even begin like this. So we have sine of x to the 4th power cosine x dx. Alright, so that's what I'm dealing with. So if u is sine of x, du dx, the derivative of sine with respect to x, is equal to cosine. Alright, and now if I multiply both sides times dx, I'm going to get du is equal to cosine x dx. Alright, so that's what it is. Now make sure, look at your equation, make sure you have what you're going to replace stuff with. So we have u is sine of x, so notice that's sine of x right here. So I have that. And then cosine x dx, well, there's cosine x dx, so I have everything. So I'm going to replace all of that. I'm going to substitute it. So I have u to the 4th power du. And I'm just going to integrate this, which is a lot easier. So if I integrate this, I'm going to have u to the 5th power over 5 plus c. And then now I'm going to replace this back. So I'm going to replace u with sine of x. So we have sine, this is sine of x to the 5th power, which I can write like this, over 5 plus c. Alright, so this is your answer again. And one more time, if you wanted to check this, you could do the chain rule. Right, so do the chain rule on this, and that should give you back to that. Alright, so let's do example 4. Now, example 4 is more like what you're going to see on your homework. The first 3 examples are just to get you used to the idea of doing this. Alright, so example 4. Alright, first I'm going to actually do this right here because that to me can get confusing when I see too many letters together. So we have they want us to find the integral of 1/2 cosine 2x dx, and we're going to let u be equal to 2x. So the first thing you can do, and it can make it easier, well, I guess I'll talk about that here in just a second. If I take the derivative of 2x, I'm going to get 2, which means that du is equal to 2 dx. Alright, so notice that I definitely have u. I have that. This is the 2x that I'm looking for. But notice that du is 2 dx. I have dx here, but I don't have a 2, I have a 1/2. Alright, so at that point, you need to figure out a way to turn this 2 into a 1/2. And hopefully it won't take you too long to realize that if you divide this by 4, well, that's going to give you a 1/2 dx. But also you can divide this by 4. Okay? So if you divide this by 4, you have to do it to the other side. So all those rules from who knows how long ago that you learned, you have to do them here. So again, if you divide this by 4, I have to divide this by 4. So that means that du over 4 is equal to 1/2 dx. Alright, so what I'm going to do now is I'm going to replace 1/2 dx, which is this right here, 1/2 dx, with du over 4. Okay, so we have this is the integral. Well, I'm going to write the cosine of u first. Cosine u, and instead of 1/2 dx, I'm going to write du over 4. And I know that's kind of very strange. However, you know, this du over 4, you can rewrite that as 1/4 cosine of u du. And then that looks a little bit easier to deal with. So now same thing, we're going to take the antiderivative of cosine. And remember that 1/4 is a constant. You can actually even write it like this if you wanted to. Alright, so if you don't want to deal with that constant, you can just write it like that. So the antiderivative of cosine would be sine of u plus c. Right, so that's the antiderivative. And then all you have to do from here is replace u with 2x. So we have 1/4 sine of 2x plus c. And that is your answer. We'll run one more time. If you get a little bit stuck, go back and re-watch this example 4, because most of your homework is going to be like this example. Okay, so let's go to example number 5. Alright, so example number 5. Now this one's when you may start doubting why you ever stayed in this class. But just slow down, watch this as many times as you need to, and hopefully you'll understand it. But at the end of the day, you're going to have to start your homework, do some problems, and if you do try, I promise you that this method will become a little bit easier as you do it. But that's the key, you have to do it. Alright, so first things first, let's just go ahead and get the derivative of u. So derivative of this right here is just 2, and well, that's it actually. And then if I multiply both sides times dx, I'm going to get du is equal to 2 dx. Now let's take a look at what we have so far. We have u. U is right here. I don't have a 2. Okay, so we can deal with that x here in a second, but I don't have a 2 anywhere on here, you know. Like outside the radical, I don't have a 2 anywhere. So I need to get rid of that 2, and I'm going to do it in the same manner that I did the last problem. If I want to get rid of that 2, well, I'm just going to divide this by 2, and if I divide this by 2, I have to divide this by 2. Okay, so far, what I have is let's see, I have dx. Alright, so I have those two parts, but notice that what I'm missing is that x. I don't have a way to replace this x yet. Alright, so what I'm going to do and this is, you're only going to have, I think, a couple of problems where you're going to have to do this on your homework. So what you do then, I cannot write the integral. I cannot write this integral as x square root, or, you know, I'm going to write this as, well, let me write it like that first, and I'll talk about why I'm going to do what I'm going to do. So this is going to be the square root of u du over 2. However, I cannot take the integral because of that x. So I need a way to replace this x. I need to write this x in terms of u. Okay, so to do that, you're going to take the original equation, which is this one, right? You're going to rewrite it. So you have u is equal to 2x plus 1. And I'm going to write over here, I need an x. That's what I need. That's why I'm doing this part right here. Alright, so if I write the original equation, what I'm going to do now is I'm going to try to get x by itself, meaning I'm going to solve for x. Because if I solve for x, then that I can replace whatever I get with this. Alright, so we have, let's see, I'm going to subtract 1 from both sides, so I get u minus 1 is equal to 2x. Yes, I'm skipping like one tiny step, but, you know, deal with it. And then now you're going to divide by 2. Divide this by 2. Alright, and then after that, what you're going to do is, notice now I have x. I have x is equal to u minus 1 over 2. I'm going to replace x, this x, with, and I wish I had a different color, I don't, but I'm going to replace this x with all of this. So I have u minus 1 over 2 times u to the 1/2 du over 2. Alright, so the u to the 1/2 power, remember that's just me rewriting the square root of u. Okay, so if I have that right there, the next step is to try to multiply everything together. So notice that this 2 in the denominator times this 2 in the denominator is going to become 1/4. Alright, so I'm actually going to write the 1/4 because it's a constant outside the radical, and then I would end up with u to the 1/2 u minus 1 du. Alright, so again, all I've done so far is just multiply this 2's right here in the denominator, and I pull out the constant. Alright, so now I'm going to distribute, and I would have 1/4 is equal to the integral of u to the 3/2, because remember that when you multiply, you add the exponents, minus u to the 1/2 du. Alright, now I can integrate this. Alright, so I'm going to integrate this. So I'm going to have 1/4 2, or you can write it like this, 2 u to the 5/2 over 5. Remember, I'm adding 1 to this power and dividing by 5/2, which will give me 2/5. If I add 1 to 1/2, I get 3/2, so I have u to the 3/2. And if I divide this by 3/2, that's the same thing as multiplying by 2/3. Alright, plus c. Now, after I've done all that, the last step is to replace or to substitute back u. So I'm going to replace this u's with 2x plus 1. So that's going to be equal to, well, hopefully you can follow me here, 1/4 times 2/5. That's just going to be 1 over 10. Okay, so that's what this 10 is going to come from. So again, this 10 came from me multiplying 1/4 times 2/5. That's where that 10 came from. Alright, now minus, same thing, 1/4 times 2/3 is going to give me 1/6. So that's where this 6 is coming from. Again, that 6 came from me multiplying 1/4 and 2/3 together, plus c. So that's that. All right, and then finally example number 6. Same ideology as the last one, except for it's going to be a little bit longer. So let me get through this one. Notice that on this one, u is all of this, including the radical. All right, so all of this, I usually don't circle it, but all of this is going to be u. Okay, so u is going to be all of that. So now du dx, let's just see what we get. Now du dx means that I have to take the derivative of this. Now remember, if I rewrite this like this, hopefully you'll be able to recognize that this is a chain rule. So you have to kind of pull in all the stuff that you know, or that you should know by now. Okay, so I'm going to use the chain rule on this. Alright, so we have 1/2 is the derivative of the outside, which is this, times the derivative of the inside, which is 2x. Anyway, so after that, I can cancel that 2 and this 2 together. And then notice that I'm going to multiply both sides times dx. Notice that I wrote the dx all the way over here. And notice that all I have in the numerator is going to be x. So I have x over this negative exponent. I'm going to bring it to the bottom and make it positive, which will make it the same thing as the square root of x squared minus 1. Okay, now if you look at it, this is a part that's going to be a little bit strange. You have perhaps one problem like this. If you look at that problem, if you look at here, you don't have, you already replaced this, so you don't have to deal with this anymore. But see, you have x to the 5th power, and that does not look like x to the 5th power. Okay, so the thing that you can do is I want to get rid of this square root of x squared minus 1. Right, so I'm going to do that by multiplying both sides times this. Alright, so again, I'm going to multiply. This is getting a little bit convoluted here, but we have x squared minus 1. I was going to cancel that, so I'm going to rewrite this. So we have x squared minus 1 du is equal to x dx. That's what we have right now. Alright, now I know, however, if you look over here, notice that again I cannot replace, well, first of all, I have x dx. Alright, so that means that this dx is getting taken care of, but this one, I only have, this is x to the 5th power, not x. So that would mean that I still have x to the 4th power that I need to deal with, alright, after dealing with this x. So, before I do that, but even if I wanted to do that, notice that I cannot replace this with this because I have terms over here that are not in terms of u. But if I look over here, I notice that u is equal to the square root of x squared minus 1. So I can actually replace this with u. So we have u du is equal to x dx. Alright? Now, let me rewrite this. Maybe you should be able to recognize better what I have left. Okay, now this right here is u. So we have u. Now notice that x dx is now u du. So I have u du. Okay, however, I still have x to the 4th power, because if I take an x away from this x to the 5th power, I still have x to the 4th power to deal with. So I have to find a way, just like the last problem, to replace this x to the fourth power with stuff that's in terms of u, with a function in terms of u. So just like the last problem, so the weird part kind of happened here, because the next part should be, I shouldn't say should be familiar, but we did it in the last problem. So what we're going to do from here is that you don't have to write this in your homework, it just helps me to understand it. I need an x to the fourth power. Okay, so if I need an x to the fourth power, that means that if I use the original equation, this one, u is equal to the square root of x squared minus 1. If I square both sides, I get u squared is equal to x to the second power minus 1. Right, now I'm going to add 1 to both sides, so I have u squared minus 1, plus 1 is equal to x squared. Now notice that I need an x to the fourth power, and I have an x squared. So in order for me to get an x squared on this side, I have to square this. But if I square this, I also have to square this. So that means that x to the fourth power is equal to u squared plus 1 squared. So I have to replace something that perhaps seemed more simple than that. I have to replace this x to the fourth power with u squared plus 1 squared. So I write that over here. So I have u squared plus 1 squared like that. Okay, so that's what I have right now. In order for me to integrate that, because I really can't at this point, is I'm going to have to multiply everything together. So the first thing I'm going to do here is I'm going to multiply this times this, which will give me u squared. And then eventually I'm going to multiply this times u squared plus 1. When you, remember this is, you have to FOIL here. Right? You have two terms that are being squared. So you have u to the fourth power plus, well, I run out of lead. Hold on. Technical difficulties. U squared plus 2u squared plus 1 du. By the way, I don't want to come back to class and you ask me how did I get that from here. All right, you should know how to FOIL by now. You're in calculus. So now we're gonna have, if I distribute this, I will have u to the sixth plus 2u to the fourth plus u squared du. Now I can take the antiderivative or the integral, which is the same thing, of all of this. Alright, so this is going to be equal to u to the seventh over 7 plus 2u to the fifth over 5 plus u to the third over 3 plus c. Alright, now final step here is I'm going to replace all of this, the u's, with the square root of x squared minus 1. So I'll write this in two steps, so hopefully you're not confused. If I have this right here, and I guess if you read it like that, I wouldn't be that upset, but I have x squared minus 1, 7 plus 2. So basically all I'm doing here